Hello everyone and welcome. My name is Sophie and I'm a second year DPhil student on the NERC DTP in Environmental Research Programme at the University of Oxford. Thank you all so much for turning up this evening and this morning for some of you to this third seminar in the Grand Challenges in Science series. I'm really excited to introduce you to this week's topic. It's on deep sea mining. The aim of this seminar is to explore problems associated with the practice and to shine a light on a potentially crucial component to a low carbon future. Our chair this evening is Ian Coles. Ian is a partner at the London law firm Mayer Brown and has vast experience in the mining finance sector and heads the company's Africa and mining practices. Ian also provides critical advice to governments and ministries on the development of the mining industry in their jurisdictions. He has been described as perhaps the most experienced mining finance lawyer in the city. Thank you to Ian and all our panelists so much for agreeing to do this event this evening and in Craig's case this morning. We're really looking forward to hearing your expert insights on the issue. And without further ado, I shall hand the seminar over to Ian.
Thank you, Sophie. Pleasure to be here, and thank you everybody for dialing into this. So as Sophie said, my name is Ian Coles. I'm head of the mining group at Mayer Brown, which is a large international law firm. I've had an academic interest in deep sea mining for quite some time. When I was at university, I was fortunate enough to have a course which was taught by Professor Louis Sohn, who was one of the architects of the UN Conference of the Law of the Sea, which kind of dates me, unfortunately, but there you go. Subsequently, I actually lectured on it at what is now Guildhall University. So in those days, that was purely academic. Things have moved on since then. And it seems to be becoming practical, although there are obviously challenges. And the name of the panel this evening is Grand Challenges, Deep Sea Mining. There are challenges, but the resources are significant. And almost by definition, the best land-based projects have now gone. People are now talking about mining on the moon, mining in asteroids. So, the deep sea seems to be a little more achievable than that. I think it's timely that people are taking a hard look at deep sea mining. The potential's huge. It's very difficult to get definitive stats on any of this stuff, but those that you can get, they say maybe there's 30% of land-based copper under the sea, more than 100% of land-based manganese, and much more than 100% of land-based nickel and cobalt. The challenges are principally economic and social, environmental, technical and operational, and legal. We have a panel of experts lined up to speak to each of these issues, so I'm not going to attempt to get into them, but just by way of sort of an introduction of some of the topics. So economic and social. So other than diamonds, there's been very little by way of production so far. Money's been raised, but companies have struggled to get to production. The most famous one, I suppose, is Nautilus Minerals, who attempted to develop a deposit in Papua New Guinea, and unfortunately, effectively went to the wall. Although there's now a sort of company that survived them, which is having another go. Most of the interest seems to be driven by strategic minerals, mostly related to batteries and EVs, which is the sort of sexy topic nowadays. Strategic minerals have grabbed the attention of, in particular, the USA and Europe, and both have issued recent papers, basically panicking because they don't have access to materials which are governed by China. There are many optimistic predictions out there. Some people say by 2026, there'll be $7 billion worth of revenue generated by deep sea minerals. By the way, that's round about the market cap of the 35th largest mining company on the planet right now. So people shouldn't get carried away by that stat. People have estimated deep sea resources of 100 to 150 trillion. Another stat, by 2030, 10% of total mining output will be from the deep sea. I suspect a lot of these are very difficult to hard down. And as a friend of mine from SRK, who is one of the leading mining technical companies, frequently comments to me, metals are worth nothing in the ground. You have to get them out. So environmental. So many NGOs, as we know, oppose deep sea mining on environmental grounds. There's now a body called Deep Sea Conservation Coalition, has around 80 NGOs are looking for a moratorium on activity. Concern is now enhanced in the context of increased consideration of ESG, so environmental, social and governance issues by investors, and also for responsible sourcing in the supply chain. And the World Economic Forum actually a couple of weeks ago just released a paper on responsible sourcing in connection with deep sea mining. Of course, land-based mining has these issues as well. The risks are still being reviewed, but many scientists predict harm in a substantial manner. We'll hear about that from others on this panel. On the plus side, deep sea mining means there's less need to mine in the Amazon, there's less need to mine in Alaska, there's less need to mine in Greenland. There's also a limited supply of battery metals on land, which constrains the move to electric vehicles. We need a massive ramp up of electric vehicles if the Paris Climate Agreement goals are to be met. Of course, some believe that particular story is oversold. Tesla's planning for batteries without nickel or cobalt. There's also hydrogen cell alternatives out there. Another environmental related issue is land-based projects of lower grades, are deeper, which means there's much more waste than with deep sea mining. The Solwara copper grade, which Nautilus was trying to develop, was 70%. On the other side, there's signs that many financial institutions may decline to finance deep sea mining on environmental grounds. Technical issues, commercial extraction at depth has yet really to occur, although many technologies have been trialed. As we all know, the obstacles are challenging. Solwara is 1,500 meters deep. The rare earth deposits just outside Japan are more than 5 kilometers down. Legal, we were hoping to have Michael Lodge, who's the Secretary General of the Seabed Authority, with us, but unfortunately at short notice he had to pull out. But I think Eleanor and I between us can probably muddle through on legal. But the framework is obviously the 1982 UN Convention of the Law of the Sea, exclusive right to mine in 200 nautical miles of continental shelf known as the exclusive economic zone. Beyond that, deep sea minerals are, quote, the common heritage of mankind, quote, close quote. It's regulated by the ISA, based in Jamaica. Unfortunately, there's a large number of countries have signed up to the UN Convention, but not all. So currently there's 168, I think, 167 countries plus the European Union. Significantly, the USA is not signed up. And I don't think there's any sign that they are going to, although who knows what the Biden administration will bring to this. It's regulated by awarding contracts. Sorry, exploration activity is regulated by awarding contracts. 30 awarded to date to 21 contractors in 18 countries. Exploitation is regulated by regulations, unfortunately not yet passed. They have been in the works for many years. They were supposed to be finalized this year. That has not happened and will not happen as I understand it. The drafts have been heavily commented on. So hopefully something will happen in 2021. There are a lot of issues in connection with the regulations. Balance between revenue and environment, capacity building, fiscal sharing. It's very, very complex. So that's sort of my 30,000 foot view. So without further ado, we'll move on to our panel and I'll introduce them one by one as they make their presentation. First up is Eleanor Martin. Eleanor is an accomplished banking and finance lawyer based in the London branch of the global law firm Norton Rose Fulbright. The firm operates in more than 60 cities worldwide and provides the world's preeminent corporations and financial institutions with a full business law service and is recognized for its industry focus in mining in particular. Eleanor has detailed experience, including advising on offshore equipment financing and asset finance matters, such as deep sea mining, and was recognized by Chambers UK 2017 as a leading individual for offshore finance. So Eleanor, over to you.
Thank you very much indeed, Ian, for that wonderful introduction. It's wonderful to be here. So thank you very much indeed for having me. I'm afraid I'm having trouble sharing my screen. So if anybody is able to put up the slide, that's brilliant. But if not, I can just continue talking. Thanks, Ryan. Fabulous. Thank you. So as Ian said, I'm a partner in Norton Rose Fulbright, which is a global law firm. We have offices in over 50 countries around the world, from Australia and China through to Brazil and Mexico. And as a law firm, we've always focused on certain industry areas to really sort of show what we can do and show that we understand those industry sectors. And those are, well, there's a number of them, but the most relevant ones for this discussion are our energy, practice, our mining and minerals practice, and our shipping practice. And so deep sea mining sort of perfectly fits within all of those sectors. The reason I came to start looking at deep sea mining is my practice focuses quite a lot on assisting the offshore oil and gas sector. So anybody that wants to get oil and gas out from underneath the sea, I help them finance it. I help them find the ships to help them do it, the drilling rigs to drill, the FPSOs, which are essentially very big, expensive ships that can get oil out from under the sea. The flotels, the accommodation for people who are living offshore, the shuttle tankers to take the oil back to shore, you name it, I do the whole gambit. And as we started looking at the oil crisis, which sort of started several years ago now for a number of our clients, they started trying to think about how else they could use the assets that they have in other sectors. So if the oil price is dropping and remains low, how can they deploy their assets somewhere else with a view to making money? And a number of them started looking at deep sea mining. There are a number of shipping companies that have actually created strategic joint ventures with some of the deep sea mining companies that are in existence today. So that's the angle that I've been coming at this from. I've helped a number of those licensees, those 30 licensees that Ian mentioned earlier, actually negotiate their sponsorship agreements under the UN Convention of the Law of the Sea, and enabling them to then apply for a license. And as Ian said, I think one of the issues that is really holding this industry back is the legal framework. So we have settled exploration regulations, which means that people can get exclusive rights to certain areas of the sea, which are in that no man's land area we were talking about, which is for the benefit of all mankind. People can have an exclusive license to go and have a little look-see. But at the moment, what they cannot do is start commercially harvesting or exploiting what they find there. And that is the thing that is really stopping this industry from blossoming. But there are a number of companies, there are a number of governments around the world who are really positioning themselves for when that deep sea mining exploitation regulation framework comes into effect. Now, what the ISA, who are the regulator for these types of licenses, have done is they've been very open and transparent, and they have published draft exploitation regulations, which have been published several times over now for stakeholder consultation. And as a result of that, what we've ended up with is draft regulations that look pretty good. I mean, they take all of the issues that I'm sure Ian would raise from a land-based mining project as being things that his clients worry about, and they've really tried to address them. And one of the key ones that they've really focused on and put in place is the environmental side of things. So one of the elements is that anybody that really wants to apply for an exploitation license has to put their entire plan out for public consultation for a certain amount of time, and then receive the feedback from whoever wants to provide that information or their views on it, and then address those in their further submissions to the ISA. So what they've done is taken something that could be an incredibly big issue for a number of people and tried to make it as transparent as possible. I was going to talk through a number of the commercial drivers, which is why you can see so many pretty pictures on this slide. But I think Ian's covered the majority of them. There is one I'd just like to pick up on, and that is that at the moment in the banking and financial institution community, there is a huge drive towards green finance and sustainable finance. And one of the questions I think it might be interesting for us to explore today is whether we consider that deep sea mining itself can fit into that green or sustainable box. So it certainly can drive forward green energy and tellurium, which is needed for solar panels and for wind turbines. not to mention the cobalt, which is essential for creating lithium batteries. So in that sense, there is a green element to it. There is also a green element to it in that it is a lot less intrusive on communities and a lot less disruptive of environments, potentially, than land-based mining. So that's just one of the ideas that it might be interesting to explore between us as we go through this seminar. But with that, I will hand over back to Ian. Thank you.
Thanks, Eleanor. So now we move on to environmental and related considerations. And the presenter here is Professor Craig Smith. Craig's a professor of oceanography at the University of Hawaii, USA. So he's just finishing his breakfast as we speak, and leads the Smith Lab, which focuses on benthic ecology. He has strong interest in biodiversity, disturbance ecology, and human impacts in seafloor ecosystems, and is a Pew Fellow in Marine Conservation. He has led 66 oceanographic research expeditions from the equator to Antarctica, including 8 to study biodiversity in areas targeted for deep sea mining. He has published in excess of 200 scientific papers on seafloor ecology, biodiversity, climate change impacts, and the design of marine protected areas. His recent Abyssal Baseline project was part of an international program that used the best available technology to undertake benthic biological baseline studies. So Craig, over to you. Craig, I don't know if you're on mute.
Okay.
There we go.
Hear me now? Okay, sorry about that. Once again, or as I was saying, I'm very grateful to be here to discuss the environmental issues associated with deep sea mining. And I would like to point out right from the beginning that I'm neither for nor against deep sea mining, but I think it's fundamental and essential that the public know the costs of deep seabed mining so they can make an educated decision about the cost versus the benefits. And just to give a little more about my background, I've been involved in deep sea ecology since I got my PhD in 1983, so that dates me. And I've been working actually on issues related to seabed mining actually from the mid 80s and onward. And I've been fortunate to visit some of the areas targeted for mining at the deep sea floor, in particular the Clipperton Clarion Zone, this region of nodules, manganese nodules in the middle of the Pacific. And I've led 8 oceanographic expeditions there, working with a lot of very talented people, and trying to understand the baseline nature of these ecosystems, their ecology, their sensitivity to disturbance, et cetera. And this work done in collaboration with lots of people has resulted in a number of scientific publications, and we've also won a number of international awards about our work in deep sea diversity, biodiversity, climate change, marine conservation. And one of my, I guess, my proudest undertakings was working with a number of very talented scientists with a Pew Fellowship in Marine Conservation to design a network or a system of marine protected areas, no mining areas, for the Clipperton Clarion Zone. And the Clarion Clipperton Zone, this area targeted for mining in the middle of the Pacific. And this, we designed a set of a network of marine protected areas to protect biodiversity and ecosystem functions in the region. And the ISA has adopted parts of that. They modified it to some degree and actually opened some gaps that need to be filled. But that's an important step forward. And one of the things I have to say is that the deep sea mining industry is the first in the history of the planet that is trying to get conservation measures in place before the activities begin. And that's a really important thing. Sets an important precedent, but we need to do it right. If we're going to do it before we go in, we need to get it right before we start mining. Some of our work in the CCZ and other areas has highlighted the extraordinary new biodiversity of the area targeted for nodule mining. There are some remarkable animals. Most of the animals we collect are new to science. That's why I say new biodiversity. really some interesting evolutionary novelties. And this is true also in some of the other areas, or all the other areas targeted for mining. They're in this Clipperton and Clarion zone, as in the massive sulfide areas and on seamounts, 3 different kinds of habitats targeted for mining. There's a specialized biota that relies on the mineral resource that will be removed. And all of these ecosystems, based on our research and that of many other people, are extremely vulnerable. They're very sensitive to disturbance, and they have a potential for very slow recovery rates. And I'll talk about that in more detail. But I think it's fundamental to understand what the costs are. In terms of ecosystem impacts, to me, it's inconceivable to think of this as green. The footprint of impact of seabed mining, particularly nodule mining, likely will be larger than any other industrial activity on the planet if it goes to the full scale that's envisioned. If all the exploration claims in place now are mined, the aerial impact will be enormous. And it's important to think about that, and whether working in these wilderness environments, some of the last wilderness places left on Earth, the costs of that are worth the benefits of acquiring the minerals. And that's a decision society has to make. I'll stop there. Thank you.
Thank you, Craig. So now we'll go on to consider some of the sort of technical issues around. Sorry, I was just getting something to all panelists. Technical issues surrounding deep sea mining. And this is going to come from Hamish Wallace. Hamish is an engineer and acting as a representative for the British engineering firm Osbourne, which specialises in the global oil and gas, subsea and renewable sectors, with an emphasis on reducing the environmental impact of such practices. The company was founded a decade ago by Dr. Tony Trapp, MBE, who is widely regarded as one of the UK's leading offshore engineers. Utilising their extensive experience in the development of subsea solutions, they are pioneering the collection of minerals from seabed surfaces, claiming that their equipment is the most environmentally viable solution currently on the market and is highly scalable and is proven to offer efficient and reliable recovery. They have recently secured government investment to expand this venture. Hamish has asked me to point out he will not be divulging any confidential secrets relating to Osbourne on this presentation. So, Hamish, over to you.
Would help if I unmuted myself. Thanks, Ian. So as Ian said, I represent Osbourne. So we're a specialist offshore engineering firm in the northeast of England, founded by Dr. Trapp. So he's one of the leading engineers in offshore trenching and subsea cable lay technologies. So starting back in the 80s with various other companies before he got to Osbourne Limited. He really was one of the pioneers in industry, and subsea trenching cable lay technology is kind of our bread and butter. It's what we do. As described, we're using this technology, we're using our experience in oil and gas and subsea trenching technologies and trying to transfer that into subsea mining. For obvious reasons, there's certain links there, which allows us to sort of transfer our technologies and try and move into new marketplaces. So a bit about me. I've sort of always worked in the offshore and subsea sector. So when I first left university, I worked at Her Majesty's Naval Base Clyde. So that was on the fast lane on the Naval Defence Programme. So my job basically was to ensure that submarines were ready for duty and make sure all operational maintenance was done. So as you can imagine, there's a lot of complexities there and a lot of key factors with safety critical equipment and reactor interactions. Probably wasn't the career for me, so I moved to Osbourne to move into a more design focused role, which is what we do. You know, we don't sell a product, we sell engineers and engineering ability. So we are really reactive to what the marketplace is looking for. So a number of the notable projects that I've worked on, you'll see photographed in the top right hand side. This is Scarjet. So this is a low pressure and high pressure hydraulic jetting trencher. So the basis of this is you can trench from shore to deep sea with a single tool, which is not common. Another trencher I've worked personally on is the T1 trencher for one of our clients. So in that, we're utilising a lot of terrestrial mining technologies and soil mechanics known from surface engineering, and transferring that to the subsea environment to allow our clients and the tools that we design to operate, as functional and to really pull from what is a really well-known industry. As described, we do a lot of work in the renewable sector. So one of the recent projects we've just completed is a pile gripper that's currently being used in the Yunlin wind farm. So that's a Taiwanese wind farm that's offering, I believe, 640 megawatts of power. So that's 450,000 homes worth of clean energy. So it's a really good tool that we've got out there. Recently, I started as the lead of project build, commission and testing for a well intervention tower. So a good deal of knowledge on how to test safety critical systems at sea, on obviously passive and active heave compensated systems. So I'm coming, I guess, from a slightly different view from the rest of the panelists. I've got a less holistic view and more specific and reactive marketplace view to where we're going with this technology. I think that'll probably summarize me pretty well.
Okay, thanks, Hamish. Thanks for that. So we're going to get into some questions for the panelists. There'll be an opportunity for those who have joined to put some questions. I have some sort of pre-prepared ones, so we'll run through those, and then we'll put some questions that are coming from those who've been listening. Eleanor, one for you, and actually this has also come from the audience, I can see. First of all, I have two for you actually. So there are 168 countries who have signed up. So what's to prevent the United States of America just going in and exploring and exploiting? I assume nothing, but you might want to elaborate. And then one of the people who've dialed in has asked you to sort of elaborate on how deep sea mining might, in anybody's imagination, qualify as green financing, which I think is a good question.
Excellent, thanks very much. So on the first one, you're absolutely right. The US hasn't signed up. Interestingly, China ratified the UN Convention of the Law of the Sea very recently and have since been significantly increasing the amount of licenses that they're seeking to hold. And actually, what we've seen is that the lack of signatory to the UN Convention be used quite effectively. So UK Seabed Resources is a holder of a license in the CCZ. And they are actually a subsidiary of Lockheed Martin, which, as many of you know, is a large US defense and other systems company. And Lockheed Martin took the view that they actually weren't able to apply for a license because the US hadn't signed up. And so UK Seabed Resources was created, which is a UK company. And the UK is a signatory to the UN Convention of the Law of the Sea. And the way it works, which may give people a bit more comfort that it is actually regulated in a very practical and sensible way, is that countries sign up to the UN Convention of the Law of the Sea, so it's ratified by governments. But what they can do is pass their own domestic enabling legislation. So in the UK, the UK government has passed a Deep Sea Mining Act, which then regulates how private companies are able to obtain licenses in the CCZ, in this no man's land, as we call it. And they are sponsored by their government. So the UK government sponsors UK Seabed Resources. And that means that they say essentially to the ISA, we'll make sure that the company that we're sponsoring follows the rules. And if they don't, you can come after us, put very, very simply. So that's the sort of way that it works at the moment. And there are a number of countries that have signed up in the Pacific Islands, so Tonga, Nauru, some of the smaller Pacific islands have signed up, and then larger countries have done so as well. If I can address the slightly controversial, and I can see Craig itching to try and head me off at the pass, the controversial position I put forward in my introduction, I think it's possibly more a commentary and a slight cynicism from me than anything else. But the idea of green financing it is fairly new, but already a significant amount of capital has been deployed towards this. There are a number of banks who can no longer do what they perceive to be dirty projects. So they can't finance oil and gas in the same way that they could do. It simply doesn't fit into their commercially green and sustainable parameters. It just doesn't tick a box for them internally. And so what we're seeing is a number of those financial institutions that were traditionally financing the oil and gas industry try and look for how they can deploy their capital elsewhere, but without perhaps looking too far away from the oil and gas industry, if I can put it politely like that. And the Loan Market Association, which sort of regulates the English law loan market, has set up some principles which need to be followed in order for you to qualify to be a green financier. And they look at the lending that a financial institution does, and they mark it according to certain criteria. And at the moment, those criteria are pretty loose. And to the extent that you would like to say that deep sea mining falls within those categories, you can probably get there. And to give you an example of how loose they are, it is possible to obtain green financing for a drilling rig which has some battery operation rather than some dirty diesel engines. So that's the sort of the level of test that is currently being applied. Now what needs to change to make sure that actually when financiers are financing these projects, they really are caring about the green and sustainable nature of them? Well, I think those principles need to be tightened, and I think those principles need to be tested. And we're already seeing some of that happen. So there was a bond issued by an offshore service company for its shuttle tankers, which are essentially vessels which transport oil to and from shore. And they marketed this as a green bond, and they were able to do so, but they were heavily criticized in the market for it, and it was recategorized as light green rather than truly green. So I think there's a confluence of things happening here, and I agree that it is difficult on the face of it to see that deep sea mining is green, but at the moment within the commercial framework that the financial institutions are operating, it does fall within those principles. But Craig, you might want to put your tuppence worth in, perhaps.
Yeah, well, I guess naively society probably looks at something that's considered green technology to me and quote sustainable to mean that involves the entire activity. And when I have a chance to talk a little more about deep sea ecosystems, it's clear that deep sea mining will have permanent impacts over major habitat areas of the sea floor, not reversible. And so in my view, if you're damaging huge areas of habitat and at least locally damaging biodiversity, it's hard to consider that sustainable. If you keep going, you'll eventually wipe out, a whole major ecosystems and potentially environmental services. So I also wanted to add something about, there's another deterrent for non-signatories to UNCLOS, or the law of the sea, to not go and mine, and that is that industry likes certainty. They don't want to spend $3 billion to get a mining operation up and then have someone else come in and jump on their claim, take advantage of all the work they've done and start mining. And the only certainty that you have control of an area in international waters at the seabed is through the ISA. And so that's actually, I've talked to Lockheed Martin folks, and that's one of the reasons they've gone through ISA, because they want to make sure that they don't go out and survey a big area and have someone else come and use all their knowledge without spending the spin-up costs.
Pursuing the environmental theme, Hamish, one of the questions I've seen from those who've dialed in is technology for deep sea mining developed with environmental objectives in mind? It's a bit of a loaded question, really, but.
Yeah, I'm not sure there's a safe answer to this question. So again, this is driven the need for an environmentally conscious system and technology to harvest minerals is not really driven by us as a design house, but more the operators and I guess subsequently the regulators who are enforcing the rules on them. We're still in its infancy in terms of commercial mining, and we're very much still in the sort of feed study end of things, where we're trying to find out what technologies really work, what is the most efficient way to get nodules to the surface. Of the systems I know of, I'm not exactly going to say that they're the greenest, but again, nobody's really looked into it, and there's never been a driver from our clients anyway towards us to integrate technologies which could be considered as preserving of the flora and fauna on the seabed. So yeah, without saying no directly to the question, I'll in a roundabout way say it's not currently under consideration.
Okay. Good. So, Craig, going back to sort of environmental considerations, how sort of potentially large do you think mining disturbances are likely to be, and how long will it take those ecosystems to recover? I guess that sort of goes in part to people's concerns about quote plume close quote, and how far the disturbance is going to be manifested.
Okay, well, just to talk about the footprint of disturbance, the scales, one has to think about which deep sea mineral resource one is talking about, because there are cobalt-rich crusts on seamounts, massive sulfides associated from extinct hydrothermal vents, and then polymetallic nodule mining. And those resources are distributed over much different areas. So I'm going to focus on polymetallic nodules at the abyssal seafloor, because that's probably the resource closest to being exploited. And these nodules occur at the seafloor. They're like potato-sized concretions, little metalliferous rocks, if you will, that are distributed over huge areas of the abyss. And in order to mine them, it's inevitable that a mining head will be put down and it'll chop up the sediment, suck up the nodules in the surface sediment, and pump them up to the surface vessel. Now, it turns out that, and in the process, this mining instrument will it will remove the nodules, which turn out to be a habitat for a specialized fauna. We found over 100 species of nodule obligate animals living in one 30 by 30 kilometer area in the CCZ. So there's a whole fauna that's adapted to live on nodules and nowhere else, and their habitat will be removed. The sediments underlying them will be removed, which is a habitat for another huge diversity of animals. And then this sediment will be, and the mining head as it moves along will create a plume from chopping up sediment and pumping out excess sediment behind the vehicle, because it won't be economically feasible or sound to bring the sediment up to the surface. The idea is to lift mainly nodules. So it'll be pumping out this big plume behind the vehicle. Plus, as the vehicle moves across the seafloor, a house-sized vehicle moving at 1 to 2 knots, it'll inevitably stir up a lot of sediment. These ecosystems have very fine sediments that are very easily stirred up, but under natural conditions, they're not stirred up generally. These are the clearest bottom waters on the planet. So in moving along the seafloor, this mining head will stir up sediment and cause a big sediment cloud that will disperse at least 10 kilometers and probably more at the seafloor. And so the scale and the mining at the seafloor is to be economically feasible. It's expected to mine 500 square kilometers per year. The sediment plume itself is, from everything we think we know about these very sensitive abyssal ecosystems, will impact an area 4 to 5 times larger. So every year, a mining operation is likely to severely impact about 2,000 square kilometers of seafloor. And if a mining, or 2,500 square kilometers, if a mining operation lasts 20 years, which is expected to be the minimum, a single mining operation is likely to cause a major impact to about 50,000 square kilometers of seafloor. And how quickly, and these ecosystems are expected to be very sensitive. The nodules would be removed or buried by a linear of sediment. They take millions of years to grow back. So they're permanently removed. This habitat for a specialized fauna is gone. And the sediment community will also take a minimum, from the studies people have done so far, 50 to 100 years, probably more. So this will be a footprint from a single mining operation of about 50,000 square kilometers. If all the exploration claims, if this really turns out to be a really important exploited source of minerals, of metals, for example, and mining keeps going because it's economically feasible and all the exploration claims that are currently licensed are mined, then the total disturbance footprint of mining is likely to be on the order of 500,000 square kilometers or more, an area the size of France, to put it in perspective. And this is targeting a specialized habitat, the nodules themselves, that harbor a specialized fauna. So, this is a permanent loss of habitat because the habitat is removed. And that's the footprint on the seafloor. There are another set of impacts in the water column. Mining will also bring up nodules and some sediment to the surface vessel. And then the sediment and dissolved metals will be injected back into the water column somewhere from the surface vessel. So it's because you don't want to take this to shore. And this will create it's called a dewatering plume somewhere in the water column that has a major potential to impact pelagic organisms in the pelagic ecosystem, which includes major fisheries, tuna, squid, etc. And if this dewatering, and we don't actually know how far these dewatering plumes will spread. They could spread hundreds or even 1,000 kilometers and still have an environmental impact, just because, again, these water column ecosystems are also not adapted to deal with sediment plumes in the middle of the ocean. These are very clear waters. And so if the dewatering plume were injected at 1,000 meters, which might be the cheapest way to do it, or within the top 1,000 meters, that would impact food webs that link to man, for example, tuna fisheries that feed on organisms down to 500 to 1,000 meters deep in the ocean, or they feed on organisms that are connected with those. There are a whole system of vertical migrators that go down in the daytime deep in the ocean, they come up at night and are fed on by commercial species like tunas, and they could be contaminated with the metals or be impacted themselves by the sediment. So the footprint of disturbance from mining, especially if all the mining license areas that are under consideration were mined, is really large, extremely large. And many of these impacts from the mining, like biodiversity loss for the nodule fauna, will be permanent. This will not come back.
One question which has just gone up while you've been speaking, Craig, is do we really have enough information to properly assess the environmental damage?
We actually don't have enough to fully understand it. We know from looking at the nature of these ecosystems that they are almost certainly the most sensitive of any kind of ecosystems on the planet to a mining disturbance, because these animals live in a very food-poor environment. They get their food from particles that are settling from the water column. If you dilute these settling particles with sediment from the bottom of the ocean that has no nutritional value, it will severely impact their ability to get food. It will affect their respiratory structures. It'll clog their gills, for example. And also, it turns out that 80% or more of the animals that live in the deep ocean use light in their ecology to find mates, to find food. And a sediment cloud, even a very thin one, will interfere with light ecology, potentially over very large areas. So we know that it's a certainty that they'll be very sensitive to these kinds of perturbations, much more sensitive than shallow water organisms that have been used as test organisms. But really getting a full idea of how sensitive they are is very difficult. And part of that challenge is that mining will go on for years in a given locality. So it's not just an acute exposure, a brief exposure to a sediment cloud. is potentially exposure to a sediment cloud for months to years. And chronic exposure to chronic stress, generally organisms have much lower sensitivity thresholds. In other words, they're more sensitive to chronic stress than acute stress. And I liken this to going to a rock concert. Lots of us like to go to rock concerts and for an hour and hear this very loud music. We enjoy it. It's not really stressful, but if we were in a rock concert situation, level of noise for a year, we would go deaf and it would affect our ability to function. And so chronic stress has much lower sensitivity thresholds than acute stress. And these ecosystems, especially those where the nodules are so deep, 4,000, 5,000 meters, we can't bring the animals back to the lab and study them for a year and look at chronic stress. It's just not possible. And to do these experiments in situ is also extraordinarily challenging. So my view is actually we will not really understand the nature and scales of mining impacts on deep sea ecosystems until a full-scale mining operation has gone on for years, potentially decades, and we've monitored it and seen how far the impact is. So one of my views is that we need to be precautionary in proceeding with mining. We should start slowly, really get an understanding of what 1 or 2 mining operations look like, see how large the area is impacted, and then proceed them from there, rather than just saying we're going to do it all, license it all, and not worry about it, because there will be cumulative impacts, both at the seafloor and in the water column, that will be very difficult to predict initially, in my opinion.
Right. Thanks, Craig. Sort of related, Hamish, one for you. Someone has asked, from a tech standpoint, which minerals do you think will be mined first, assuming they are mined?
So I know polymetallic nodules, there's quite a lot of benefits to them. So obviously they are mostly on flat seabed, which from a harvesting perspective, there's obvious benefits to having a sort of consistent seabed to work with. There is some unique challenges surrounding collection of these nodules. So the sort of mud that they live in it proves to be quite hard to actually physically extract nodules from this mud. It's quite it's almost like clay. It's like sticky. It doesn't want to give up nodules too easily. But having big fields and large selections of them really it allows there to be scalability of whatever mining technology is developed. It seems to be the way forward, and obviously with the battery benefits that comes out of it, and there is a marketplace and definitely an interest in trying to develop technologies in this field and trying to get them commercially viable.
Okay, thanks for that, Hamish. Eleanor, a couple of questions in connection with the Seabed Authority. There seems to be a sort of large amount of either skepticism or cynicism about the Seabed Authority, and it's sort of maybe that's sort of come about because the time's taken to get the exploitation regulations going. But do you believe the Seabed Authority has the capacity to effectively A, monitor licenses, and B, then develop sites, which is part of its remit over time? And I know there's been suggestions elsewhere that some of these functions might usefully be sort of, if not outsourced, given to some other independent body, but of course they have to be financed. But I don't know if you've got a view on any of that.
I agree. It's one of the big challenges, and it's one of the most important things that will need to happen, because if this is going to work, then it needs to be very, very carefully monitored, and we need to make sure that actually there are the funds and the organisations there to support the monitoring and to be able to serve a sort of cessation order if necessary, and further to be able to call on sort of the environmental guarantees and to make sure that things are being done properly. I think there's several ways of looking at it. It's a shame that Michael Lodge isn't here, because I'm sure he'd be able to answer it much more eloquently than I would. But I think perhaps one of the ways of looking at it is that the idea that these areas of the sea, which are for common heritage, the idea is that any profit or a certain amount of profit that's taken from those areas is used for the benefit of all mankind. And so one of the probably most difficult areas of the draft exploitation regulations at the moment is looking at the royalty structure, because it's essential that sufficient funds do come into the ISA for them to do and properly operate and police all of these issues that we're talking about. So my hope is that the royalty structure will go some way towards that. But then to Craig's point, you need to be very sure that you don't start with a big bang, so that there's an awful lot of royalties coming in to fund those monitoring processes. But actually we do more harm than good during that time.
Thanks, Anna. Actually related, Hamish, are there any technologies that could be used to preserve marine life on the seabed?
Yeah, there is. So obviously the information I think that we are missing potentially is exactly a detailed breakdown of what sea life we're trying to preserve and the best means by which to preserve it. Obviously everyone has their own drivers and needs, and we need to better understand the way that these the sea life interacts with the seabed, and subsequently explore ways to try and remove them from harm's way. Obviously, as discussed, all of these technologies are highly invasive. If you're using some sort of riser system to bring nodules to the surface and suspended fluid, you're looking at effectively sucking sea life off the seabed and trying to pull anything out of that flow and being selective is much more difficult. You would potentially look at some sort of system. So before you got to the inlets to whatever your collection machine is, something potentially to liquefy or blow away any animals that might be living on the seabed. But again, as far as I'm aware, there's not sufficient research and technology and an understanding of what these animals are and how we should be avoiding them. I think there's I'm obviously no marine biologist, and my understanding of animals under the seabed is fairly limited, so I'm not going to go too far into it. But anything living on the surface, you can deal with. You can deal with the stuff. It's the stuff that's living below the surface that is a concern to us and is one of the harder things to work around. Animals, they live in all sorts of crazy places and do what they need to do to survive, and it's challenging. It's not, as with everything that we design, we're not actively looking to cause damage and harm things. That's in nobody's interest, and it's certainly not what we stand for as a company. Or the design, some of our pilot mining vehicles that we have in operation are considerably less damaging to the seabed and to the animals that live down there than some of the other technologies that are under consideration. We're not. I don't think the industry is bought into the idea of having a sort of riser system where you're pumping nodules to a vessel on the surface. It lends itself to it. You can pull experience and knowledge from oil and gas, and it's an understood system, but it's by no means the way that this technology will advance, and by no means the way it's going to go. And I think there is options, but like I say, it needs more time and more money to properly understand the best way to mitigate these damages.
Great, and here's one from the floor, which might...
Could I just comment on that?
Yes,
Ian,
of course.
just because that is, Hamish has talked about seafloor ecology, which I think I'm an expert on, and I can say categorically that there's no way that you can mine manganese nodules without destroying the community in the areas directly mined and over much larger areas from the plume. You can't blow the animals away. Number one, that would damage them. Number two, they're attached to the substrates. We have to accept that as fact, that mining will completely destroy the communities in the areas directly mined and over a substantially larger area. And there's no way to eliminate that. There are ways to mitigate the scale of impact, and that could be by mining smaller areas. There may be other technologies that don't create as big a sediment plume as the seafloor. Not using riser technology, for example, so you don't end up, if you don't inject in the midwater a midwater plume, that would be another way of mitigating things. But to suggest that mining, removing the habitat for these communities is not going to destroy them is just not true. It'd be like saying that we can go into the Amazon and cut down all the trees and dig up the soil to 5 feet, and we're not really destroying the community there. Yes, we are. And so we have to take that as a given. Mining will be devastating locally to where it occurs. And we have to plan for that and then figure out how we can manage that in a way that we don't have compromising of ecosystem services in the ocean and significant loss of biodiversity.
Okay. Little divergence of view, but anyway. So this may be for both Craig and Hamish. This question from the floor. Is the footprint for mining the same for nodules, sulfides, and crusts?
I can answer that, I guess, because that's really an ecological question. And the answer is they're not the same. And the potential ecological impacts are quite different too. The footprint for manganese nodule mining we've talked about is potentially vast, if it's really done at the scale people are talking about. Massive sulfide mining, a typical mine will probably have a direct footprint of a few square kilometers, because these are piles of ore that are deep, tens of meters deep, very concentrated in a single location. So the direct disturbance input will be quite local, impact will be quite localized. But this will also, massive sulfide mining will also create plumes in the water column. If there's a dewatering plume, there'll be impacts in the water column. There'll also be a seafloor plume. And I must say, I'm not a hydrothermal vent ecosystem ecologist, but my biggest fear for massive sulfide mining is that plumes will be created that then disperse along this axial valley system. These massive sulfides occur in mid-ocean ridges, often in valleys where there are specialized faunas that are dispersing up and down along these valleys to remote communities. And this massive sulfide mining may create plumes of sediment that then prevent larvae, interrupt larval dispersal of connectivity of these very isolated ecosystems or island-like ecosystems that are distributed like pearls in a necklace along the mid-ocean ridge. So the local impact will be small, a few square kilometers of direct mining of massive sulfides, but there are big concerns about the plume effects over broader areas. Seamount mining will also have a lower, if it goes forward, will also have a lower spatial impact than direct impact than mining the abyssal seafloor, because seamounts are generally small. It's a few tens of square kilometers, maybe 100 square kilometers of area that might be mined, but it will be very devastating to the seamount ecosystem itself. And seamounts have their own biotas. They are hotspots of biodiversity. They're actually protected by the FAO and by the Convention on Biodiversity as special ecosystems that require special protection. So the impact will be smaller, but in terms of affecting a specialized fauna, there also will be major impacts. So bottom line is they all have significant impacts. The scales are different, but the scales of the communities they're affecting their distribution scales are also different. Seamount communities are distributed over much smaller spatial scales generally than communities on the abyssal seafloor where the nodules occur.
Thanks for that, Craig. This relates to a question that came from the floor, which was, if deep sea mining really gets going and starts to generate a huge amount of revenue, it's going to drive down the price of minerals globally, which will have a tremendously adverse impact on some of the emerging markets who rely on commodity revenue to drive their economies. I know there's been a recent ISA proposal for a compensation fund for terrestrial countries in that circumstance. I just know from a 30,000 foot view, I don't know the details. I think some have argued it offends against the common heritage of mankind principle by dishing out money to relatively limited countries. I think most of the countries who would be adversely impacted are actually in Africa. And also that it adversely impacts the ability to do deep sea mining economically. I don't know, Eleanor, have you sort of had any exposure to that proposal or any thoughts on it?
Yeah, it's an interesting one, isn't it? And I mean, I think it depends on the scale of deep sea mining if it does get going, as to whether it would have such an adverse impact. I mean, I do know that certainly, I think it's about a year ago now, the price of cobalt was so high that I think it was Volkswagen made their announcement that they were going to produce all of their cars in an electric form. And they went out to the market to try and secure enough cobalt to be able to do that at a sensible market rate. And they were unable to do that. Again, which is one of the sort of factors that leads us towards thinking that perhaps deep sea mining is something that could be helpful to happen in order to produce enough of the raw material that we need in order to have a greener economy. But I guess the other point there is that, and this is particularly the case for polymetallic nodules, they are several different commodities fused together. And I think the bit of the jigsaw for me that not enough people are focusing on is to make sure that we have a smelting process for those polymetallic nodules that really works. So Ian, you probably can talk more eloquently than I can on this, but my rudimentary understanding of smelting is that it's very difficult to preserve all of the different commodities that you have out of a set of polymetallic nodules. So you have to decide before you do it, okay, we're going for cobalt here and nothing else, or we're going for manganese and nothing else. And if we can get the smelting process right, if the technologies can be developed, then it may be that actually polymetallic nodules lend themselves very well to not having such a detrimental effect on developing countries who rely on these resources for their income. Because actually, it could be that through the royalty structure, the ISA may be able to control what is and what is not produced at any given time. So a lot of that depends on the technology for smelting, I would say.
Right. It is difficult. I think you've got a similar issue with rare earths as well. Sort of, you know, if you're going to go after those, trying to separate them is incredibly mucky stuff. So Hamish, would humans be involved with the extraction of ore at depth, or would everything be by robot and remotely controlled? What's the technology look like there?
Well, I mean, so the depths we're talking about, we're pretty well exceeding what humans can go. Obviously, that brings with it some interesting challenges, particularly with regards to maintaining equipment that's going on these deep dives and what you do if you have problems. Obviously, so you know, in recent sort of decades, the ROV technology has come on massively, which is effectively allowing us to have eyes and ears on the seabed and interact with equipment that's, like was said, potentially up to 6 kilometers deep. You know, we can send, ROVs down to interact with, the equipment. But ultimately, we're well out of the reach of humans. So saturation divers, who are obviously used quite commonly in oil and gas, they're getting nowhere near those depths. It fully depends on what the commercial mining spread looks like. We talk a lot about the riser systems where we're pumping to the surface and we have a plume that's been spat back out into the ocean. Because that's not the only thing on the horizon. And now modular setups are potential. And with modular, you're looking at having staging areas at different water depths. So there is potential that we could have humans who are able to reach. Again, I would imagine it would be a sort of saturation diver, context, but mostly we're looking towards robotics and automated systems for collection and harvesting.
Okay, thanks for that. Craig, here's one for you. Can we put the genie back in the bottle, assuming the genie escapes? Is there any way to restore the seabed to its original condition once operations cease? This will be way after any of us have ceased to live on this planet, I believe. But anyway, speculate.
Well, the short answer is no, especially for nodule mining. When you look at the scales of the environmental impact, we're talking about ultimately hundreds of thousands of square kilometers of impact where nodules are removed or buried. And the cost of putting nodules back down or some similar structure would be astronomical, probably as expensive as harvesting it in the first place. And combined with that is the challenge of we don't even know whether any structure we put down would actually be a suitable recolonization substrate, a mimic of nodules. And in order to understand that, the colonization rates of these in the deep sea are so slow that we need to do the experiments probably over decades to see whether or not we have an experimental substrate we could put down or a restoration substrate that mimics the nodules. And to get them back to the seafloor, you can't just drive along with a ship and shovel them off the back of the ship because they'll rain down and just pound into the sediment and disappear into the sediment and make a big cloud of sediment as you go. So in order to put even these substrates that we don't know if they're good mimics or not down, we would need to go down with an ROV, remotely operated vehicle, and carefully place each of these down in the sediment so they don't sink in, so you don't bury them from the plume from the ROV, which probably would occur if you move along the seafloor with a remotely operated vehicle. You resuspend sediment that then deposits on the substrate that you put down. So I think logistically, because of the scale and our lack of knowledge of what the right substrates would be, it's not possible to restore nodule habitats. And I'm talking about the nodules themselves. The sediments are also an important habitat, as Hamish pointed out, and they're going to take decades or centuries to restore. We know that from studies that have already been done. And so you would need to somehow reproduce these sediments over hundreds of thousands of square kilometers, which is not possible. So the bottom line is that habitat restoration for polymetallic nodule mining is not feasible. And we shouldn't grasp at the straw of saying, oh, well, we'll fix it later. Let's do it now, and then we'll fix it later with habitat restoration, because that's not going to happen. Now, it's probably also true for seamount, cobalt-rich crust and seamounts and massive sulfides, where again, I don't think habitat restoration is feasible, but those are occurring on such smaller spatial scales that maybe the habitat loss directly impacted by mining is not as big an issue. It may not be as large an issue, so that there may not be as much need or desire for habitat restoration. But I think in all of the cases, it would be enormously challenging to restore things, and shouldn't be something we're planning to do in the future and just say, okay, we'll damage things now, but fix them later. That's not a reasonable approach.
Right. So I think we've gone past the time we're allocated for this part of the panel presentation. I've been selecting some questions from the floor as we've gone along, but by no means any large percentage of them. It's very encouraging to see how many there's been while we've been chatting. So I think, Sophie, Tim, I think there's an opportunity for people to ask questions live, so to speak, to the panel. Is that right? Can we go there now?
Yeah, we can. You can just say their name, and if they want to, they can speak up. Yeah.
So I do that after Q&A that I've seen, right?
Yeah. If the people are happy to speak up, otherwise you can maybe read the question out. Yeah.
Okay. There are quite a few anonymous. So this is from David. This is for Craig. Is there likely to be an acceptable level of use of deep sea minerals, such as 30% of nodules and nodule areas, including plumes, that will not cause serious harm?
That's a difficult question to answer. I mean, serious harm, locally there will be serious harm wherever mining occurs. Use of 30% of nodules, I think it's really hard to answer that question until we really have a better understanding of the scales of impact of a single mining operation. And if you look at the way the mining, the regional environmental management plan from the ISA is set up in the Clipperton and Clarion zone, this area has been divided up into 9 ecoregions, that each of which is expected to have different communities and should have its own protection. And if all of the mining that was allowed occurred in one of these ecoregions, there's some of them that 50–60% of the total area is actually under exploration contract licenses. And if all of those contract licenses were exploited within this ecoregion, I think there's a very good probability of substantial species extinctions going on in that environment. So it really depends on how each of these, because the impacts from a single mining operation are permanent, you can't deal with them in isolation. If you mine if you have 3 mining operations, you mine 30% of the CCZ, but it's all in one area, one of these ecoregions, then I think there will be very serious harm and potential species extinctions. If these are dispersed broadly enough that they're not interacting, then it might be more sustainable in terms of biodiversity impacts. But we really don't know how far apart they have to be for them to avoid interacting, especially for the water column effect. So I think that's a challenging question to answer until we fully understand what the impact of one full-scale mining operation is over a long period of time.
Right. By the way, there was a poll at the start of the panel, and somebody's commented it's interesting to see that 60% said that DSM can happen. I'm not sure if that was can, should, or will, but anyway, there's obviously a high percentage of people who think something is going on out there. Let's see. Eleanor, one from Kathleen. Are the draft regulations from the ISA, I assume in relation to exploitation, publicly available?
Yes, that's absolutely right. They are. They're on the ISA website, so you can take a look. And the ISA also publish the stakeholder submissions as well, so you can see what different stakeholders are saying about the terms of those regulations.
Right. Here's one from Tom, which is definitely for Craig. What impacts might DSM have on pelagic ecosystems?
That's a good question, and it has the potential to have a lot of impacts, and we're still getting, because these pelagic ecosystems are so poorly studied, especially with relation to nodule mining impacts. It's different, there are a lot of unknowns here, but we do know that, I mentioned this earlier, that many of the organisms in the water column pelagic ecosystems are suspension feeders. They're feeding on very small particles of organic matter that are sinking or drifting in the water column with mucus nets. They have these sticky nets that they capture particles from. And if you have a sediment plume, which is composed of mainly sediment particles that are not of any nutritional value, these particles will clog the mucus feeding nets of these animals, and will very, very likely, certainly above a certain threshold, which is probably very low threshold concentration, interfere with their feeding and interfere with their interaction with particles in the water column. You might say, well, why do we care about these suspension feeders? Well, first of all, they're very important in the global carbon pump. They are capturing particles in the water that sink down, organic carbon that's sinking down through the water column, putting it in pellets that then sink down to the deep sea floor. So they're a major component of the global carbon pump, sequestration of atmospheric CO2 into the deep sea. They're also very important in food webs that connect to tuna, to squids that then are fished and consumed by humans. So if you affect these suspension feeding food webs in the water column, that has a major potential to come back and damage food webs coming to humans. A third potential or second major source of impact are dissolved metals that would be reinjected from a dewatering plume. And it turns out that most of the mercury that gets into the marine food webs and that gets back to man occurs in these midwaters, 500 or 1,000 meters or so, where they're picked up by animals that are then migrating up and fed on by tuna, for example. And so Mercury is a heavy metal. If there are heavy metals associated with dissolved metals from the nodules that get re-injected down, they also may enter human food webs by being taken up by these midwater organisms. There's another set of impacts related to light ecology. I mentioned this earlier, but about 80% or more of the animals living in the deep sea, especially in the water column, use light to find mates, to find prey. They have, some of them have big, like headlights, that they're looking for prey that they capture, or they signal to their mates. And this light ecology will be disturbed by any kind of the haze created even by a very dilute sediment plume. And then there are sound impacts, probably especially associated with things like massive sulfide mining and cobalt-rich crust mining, where grinding up the mineral ores will make a lot of noise that will interfere with marine mammal ecology, fish ecology, et cetera. And some of these resources are in what we call the SOFAR layer. This is a special sound channel between, I think it's 700 and 1,200 meters in the ocean, where sounds can be literally heard across oceans, because this is a channel that transmits sound over huge distances. So if you mined in that SOFAR channel, you would create noise that could interfere with the ecology of organisms thousands of kilometers away. So these are all things that could happen. Some of them, I mean, there's a high likelihood that plumes in the water column will interfere with suspension feeders and food webs that connect to humans. But we still don't have a good handle on how large an area, whether it's 100 kilometers, 1,000 kilometers, whether these plumes will last for months or years. There are still a lot of unknowns, and a lot of work needs to be done in characterizing these ecosystems.
All right, thanks. I'm sorry to keep the spotlight on you, Craig, but a lot of the questions relate to environmental issues. This one's from Yao Zhu. Could you elaborate more on your work on the design of marine protected areas with the ISA and others?
Sure. Actually, I've been involved with a number of efforts to design marine protected areas. And again, I think that we need to applaud the ISA for putting in, before mining, these regional environmental management plans that include no mining areas that protect biodiversity. And I can't really go into the details of these marine protected areas or areas of particular environmental interest. They're called in the CCZ. But basically what we did is we took what we knew about the ecology and biogeography of abyssal ecosystems and how far that we think they disperse, and how large the length scales associated with plumes likely to be generated by mining might disperse. And we selected on a size of protected area that's large enough to be, we think, self-sustainable, and be buffered from plumes from mining, as you know, on the edge of the protected area. So that, and they end up being 400 by 400 kilometers, 400 kilometers on a side with a 200 by 200 kilometer core area which we expect would be buffered from mining influences. And we distributed these across the CCZ in a way that we thought would capture, in our recommendations, all the habitat heterogeneity, including seamounts and different areas of nodule abundance and lower nodule abundances, so that we could capture the full habitat diversity of the region in these 9 protected areas. It turns out that for a variety of reasons, the ISA took 2 of these protected areas, the locations of these protected areas, and moved them from the core to the periphery of the Clipperton Clarion Zone, away from the richest nodule belts. And what we found in a recent paper that's just been accepted for publication is that because of moving these 2, the locations of these 2 protected areas, now nodule-rich habitats are very poorly represented. They're underrepresented in the protected areas. So there needs to be some fine-tuning of these protected areas, no mining areas. We need to add some that protect areas of high nodule abundance so that the nodule-dependent fauna is well protected as other components of the fauna. And since the nodule-dependent fauna itself or the nodules are particularly targeted, their fauna are at the highest, the fauna of the nodules is at highest risk. So we really need to make sure that we add some additional protected areas to this system that protect nodule-rich habitats.
Good. Eleanor, somebody had a question for you in relation to sort of the development of regulations by the Cook Islands and other places in the South Pacific. Do you have a sort of view on how that's going and sort of their ability to implement adequate regulations and the like? Don't know if that's something you've looked at.
Yeah, so actually, the FCO has been very, very active in assisting a number of these developing countries in producing their own domestic legislation. So actually, the legislation has been designed and put together with a lot of information and a lot of background and knowledge to it. Now, the question that I think is possibly more on people's minds is whether, in fact, those developing nations have the ability, the funds and the means to ensure that that legislation is followed. And that's a question that remains to be seen, I guess, at this point in time. The only thing I would say is that one of the principles of the UN Convention for the Law of the Sea is essentially to try and assist developing nations in enabling themselves to get economic value where they can. And so that is a sort of fundamental principle that does run through the UN Convention for the Law of the Sea, hence why the FCO has been so active in assisting them, in enabling them to perhaps capitalize on these opportunities. But I think it's a good point and well raised, and it will remain to be seen.
Right. And a technical question for you, Hamish, is could expertise from other offshore industries be used to develop and inform deep sea mining methods?
Yeah, so I think as previously mentioned, oil and gas obviously is one of the ones that we're pulling a lot of knowledge from. It's one of the offshore industry where you're actively interacting with the seabed, harvesting a material and taking it back to the surface. So there's some obvious connections with what we're trying to do in deep sea mining and oil and gas. As mentioned before, that's not really, that wasn't our background massively. So we come from cable lay and subsea trenching, which is all about the soil mechanics and understanding how we interact with the seabed and using it for laying down obviously cables, connecting power, across large bodies of water. So there is, those are two industries which I think really lend themselves to it. Obviously, with anything where you're collecting a natural mineral off the seabed, there is going to be unique challenges faced with the interaction between the thing you're trying to collect and the seabed itself.
Right. So I think we're coming to the end of our allotted time. So first of all, if there's anybody on the floor whose question I haven't asked, would like to have asked and would like to sort of put it personally, feel free to do so. Okay, well, hopefully we got through most of them. As you'll have seen, a lot of them were environmentally related. So I have one final question for the panelists, and that is, what or where do you predict the first viable deep sea mining project beyond diamonds will occur, geographical and/or commodity? Also, when? You don't have to answer that, but it'd be helpful if you sort of offered some closing comments as well in connection with this before we sign off. We're going to pick to go first. Well, we're going in the order we started. So, Eleanor.
Okay. I think I would predict that the CCZ will be the first area. I'm not going to lay a bet on which company or which government is going to go first, but I do have my suspicions based on how advanced people's exploration is. And I'm going to make a really bold prediction that the exploitation regulations will be in full force and effect within the next 5 years. Okay.
Craig, I know you previously said you were agnostic as to mining, so I think you can answer this one.
No, I didn't say I was agnostic. I think I said I was neither for or against it. But okay. I think it's important for people to understand what the impacts would be. I guess I think there are a lot of challenges to getting deep sea mining going, including cost sharing or profit sharing and all these issues. So I'm not convinced it will happen. I think if it does happen, it will happen first in the CCZ. nodules. I do think there's a lot of political will. The whole UNCLOS, the United Nations Convention on the Law of the Sea, was set up to mine the deep sea floor, essentially. So I think there's a lot of political will in that. I think if it does happen, it'll probably be in the next 5 to 10 years will be the first one. But I also, as a closing comment, I think it's worthwhile for everybody to step back and take a look at things from a global scale. And I'm actually involved in a working group talking about comparing impacts of seabed mining and terrestrial mining. And one of the things the terrestrial mining people said is that seabed mining will not replace terrestrial mining. So the impact of mining will not go from the land to the sea. The impact of mining globally will just be extended to the sea if seabed mining goes forward. So we'll potentially double or triple the area or the nature of impacts from mining on the globe. And so it's worth considering, do we really want to go that route in these wilderness areas in places where we still don't have a good handle on what the impacts would be? So that's something to consider. It's not either or, it's both. It's one or both. It's either terrestrial mining or terrestrial mining and seabed mining.
Right. Hamish, you got a view on this?
Yeah, so I think my feel in the sort of sense we get is that, you know, the CCZ is where we're going to go first. The polymetallic nodules, you know, there's obvious benefits, and it seems to be where the real driver is in industry to move towards. I think I agree with the timeline that's been outlined of about 5 to 10 years. It seems to be about right for where the technology is at. And there seems to be a clear way forward with support coming from operators and regulators to try and develop the technology and move forward. Yeah.
Okay. I have no idea, really. I think getting finance is going to be a very, very serious issue for this. And investors, particularly with ESG issues, are going to be very, very skittish about it. Notwithstanding the fact we do have a sort of a regulatory way of going forward. That was first contemplated in 1982 or whenever it was, and the world has moved on since then in terms of environmental considerations. But you know, there's a lot down there, so who knows? So Sophie and Tim, I think we got to 7 o'clock precisely. I've never done that before. I don't know, is there anything else you both want to say before we sign off?
I just want to say thank you all so much for turning up. The questions have been like fascinating. I'm not an expert in it, but I've definitely learned a lot. And thank you as panelists and Ian as our chair for taking the time out of your evenings and mornings to come and do this. It's been really interesting, and I think we've all learned a huge amount about this quite difficult, quite grey area. Yeah, so thank you very much. Thank you.
Pleasure. Thanks, everybody.
Thanks, everybody. Thanks, Hamish. Thanks, Eleanor. Thanks, Ian.
Thanks,
this has
all.
really been very useful and informative.
Right.